Imagine a missing planet, a cosmic ghost from the dawn of our solar system, responsible for the very existence of the moon. New research is rewriting the story of this lost world, suggesting it was born much closer to the sun than we previously thought. This revelation isn't just about ancient history. It's about understanding how planets like Earth came to be. For decades, the prevailing theory about the moon's origin has been the giant impact hypothesis. This theory posits that a Mars-sized object named Theia slammed into the early Earth approximately 4.5 billion years ago. The colossal collision ejected vast amounts of debris into space, which eventually coalesced to form the moon. Think of it like a cosmic billiards game, with Earth and Theia as the colliding balls. The problem? Theia vanished long ago, leaving behind no direct physical evidence to confirm its existence or pinpoint its origin. And this is the part most people miss. Without concrete evidence, scientists have been left to piece together the puzzle using indirect clues. But now, a groundbreaking study by a team of astronomers from France, Germany, and the United States offers a compelling new perspective. These researchers embarked on a kind of planetary reverse engineering project, analyzing ancient rocks from both Earth and the Moon, including samples brought back by the Apollo missions. One of the things about this research that does make it so exciting is not only is it helping to paint a picture of what happened to the Earth 4.5 billion years ago, but also it's able to almost exactly pinpoint where this object came from, explains Jake Foster, an astronomer at the Royal Observatory Greenwich, who wasn't involved in the study. We're talking about a planet that doesn't exist anymore, and yet with a good amount of precision, we can figure out where it came from. Their approach involved examining isotopes within the rocks. Isotopes are variations of elements that have slightly different atomic weights. These isotopic fingerprints are created by the unique temperatures and conditions present during a planet's formation. Since Earth and the Moon are known to have remarkably similar metal isotope ratios, teasing out Theia's contribution has been a major challenge. But here's where it gets controversial. Whoa, the extreme similarity between Earth and the Moon has even led some to question if Theia was a truly distinct planet, or perhaps a captured Trojan asteroid that shared Earth's orbital path. The researchers focused on isotopes of elements like iron, chromium, zirconium, and molybdenum. By creating complex computer models and running hundreds of simulations, they tested different scenarios for the early Earth-Theia system. These models allowed them to determine which combinations of materials could produce the isotope signatures we observe today. Because the inner solar system was warmer than the outer regions, materials formed closer to the sun have distinct isotopic patterns. The team's findings suggest that Theia most likely originated in the inner solar system, even closer to the sun than the early Earth. This is a significant departure from some earlier hypotheses, which propose that Theia might have formed farther out. And this is the part most people miss. The location where a planet forms drastically influences its composition and potential for harboring water and other life-supporting elements. This discovery has profound implications for our understanding of planet formation and evolution. It opens up new avenues for research into how planets grow, collide, and change in the early stages of a solar system. It highlights the dynamic and violent nature of the early solar system and provides valuable insights into the processes that shaped our own planet and its celestial companion. But here's where it gets controversial. If Theia formed so close to the sun, how did it manage to collide with Earth without being ejected or destroyed by the sun's gravity? Could there be other factors at play that we haven't yet considered? What do you think? Does this new evidence strengthen the giant impact theory, or does it raise more questions than answers? Share your thoughts in the comments below.